So we just got done looking at sum and difference identities for the cosine. What we're going to do next is we're going to develop some formulas for the sum and difference identities for sine and tangent. Okay, so similar ideas, similar types of formulas, but we're going to be looking at the sine of a plus b and the sine of a minus b and the tangent of a plus b and the tangent of a minus b. Okay, so those are the formulas we're going to be looking for coming up next. I do have up here the two sum and difference identities for cosine, just as a reference. And also we looked at the cofunction identities, the relationship between the sine and the cosine. And I have one of them written here, which we're going to use to derive a formula for the sine of a plus b. All right, so let's get at it. The sine of a plus b. Well, if you consider this cofunction identity, and theta being the angle a plus b. A plus b is just the sum of two angles, but it itself would be an angle, right? The sum of 15 and 8, is a 23-degree angle. 15-degree angle and an 8-degree angle is a 23-degree angle. And so the sum of two angles will itself make an angle. So if we want the sine of a plus b, consider a plus b as being this theta, all right? So wherever there's a theta, we can replace it with a plus b. So using the cofunction identity, we would say that that is the cosine of 90 minus, well, instead of theta, let's use a plus b. Okay, so this expression, a plus b, is really the theta in the cofunction identity. So here, we also have theta, all right? Now we'll do a little bit of algebra. So we're going to distribute the minus. So we have the cosine of 90 degrees minus a minus b. And then I'm going to do a little bit of regrouping. Okay, so I'm going to regroup 90 degrees minus a and the minus b together, two different angles. So cosine of 90 degrees minus a, all minus b. All right, so now I've created another angle here, 90 minus a and b. And there's a difference between those two angles. So now I'm going to look back at the cosine of a difference, and I'm going to consider the a in this formula to be the 90 minus a that we have here. And then the b, this b, is going to be this b. All right, b and b are the same, but the a's are a little bit different. The a in that formula is the 90 minus a in this one. And so anywhere there's an a up here, I'm going to replace it with 90 minus a. All right, so this becomes the cosine of, instead of a, it's going to be 90 minus a times the cosine of b, right, that's this guy, plus the sine of a. Now instead of a, it's 90 minus a, times the sine of b. All right, so we've utilized the difference identity. All right. So we used a cofunction identity up here, did a little bit of algebra, and then utilized the difference identity for the cosine. I'm not writing all the rationale out to the side, but we could do a two-column proof sort of idea here as well. I'm just kind of verbalizing it to you as we go. Then the cosine of 90 minus a, well, consider this as part of your cofunction identity, right? It's right here, cofunction identity, cosine of 90 minus theta. Well, theta, a, it doesn't matter what we call the angle, it's still the sine of theta, or in this case, the sine of a. We also have a cosine of b. Now this also is a cofunction identity. The sine of 90 minus a, remember we had a second cofunction identity, actually we had 6 of them, but the other one said that the cosine of theta equals the sine of 90 minus theta. We talked about that one in a prior video. And so the sine of 90 minus a is really, or 90 minus theta is cosine theta. So we'll call that cosine of a. And then we also have our sine of b hanging out on the end. Okay, so this is sort of a, this new formula is an application of multiple different formulas. We're actually utilizing two cofunction identities and the difference identity for the cosine in order to create a new formula for the sum, the sine of a sum, okay? And so our new formula, and I'll write this in a different color up over on the side here. Our new formula is going to be the sine, of a plus b is equal to this, sine of a cosine of b plus the cosine of a times the sine of b. Right? This is a formula now for the sine of a sum. We call it the sum identity for the sine. There is a similar difference identity for the sine as well, the sine of a minus b. And I can go through and derive this in a similar way that we did where we went from the cosine of a minus b to the cosine of a plus b. You just replace the b here with a negative b and then go through this, use an odd even identity. I'm not going to go through all the details right now, but you would utilize an odd even identity to pull a negative out, and what you will end up with is a similar formula just with a minus in the middle instead of a plus. Okay, so you'll end up with the sine of a cosine of b minus the cosine of a sine of b. Okay, so that will be your difference identity for the sine. All right. There's obviously some similarities and differences between the formulas for the sine and the cosine. In the cosines, you have, in the cosine formulas, you have both the cosines together and both the sines together. Whereas in the sine formulas, you have sine cosine, and cosine sine, cosine sine. So you have a combination of the two rather than just having them all together. And then with the cosine formula, you have the sum formula relating to a subtraction and the difference relating to an addition, which is a change in the sign. But with the sine formulas, the plus and the minus go together. Okay, so those are just some differences between the two formulas, or four formulas I should say, and how they relate to each other. Okay.